Hey, how's it going, everybody? Today we have a pretty great problem for you guys, right? I'm pretty excited about it actually. So let's quickly go ahead and read the problem statement, guys, right? So the problem is called 2 sum 4. Input is a BST, right? So we know that this is going to be a very good one, all right? So he says given the root of a binary search tree, right? And an integer k, return true if there exists a two element in BST such that their sum equals k, right? Or false otherwise, right? So this is a very, very simple problem statement and very clear and to the point, right? So we've given a binary search tree integer k, return true if there exists two elements, right? Or in the BST such that their sum equals k, okay? Very similar to that other problem that we did, guys, which is called two sum, which is a very, very good introductory problem to LeetCode. When we first started doing LeetCode, it's a very, very good one, guys. Right, so I highly recommend you guys go out check out that video so you guys understand everything right that's going on here. Okay, so we'll give you this example. So the only different thing is the data structure, right? So which one's a binary search tree and the other one was an array, right? So very, very similar concepts, right? The way they're solved, okay? So we're given this root of a binary search tree, all right? So given this binary search tree, so then this integer k, right? We need to find out if there's these two numbers in the BST, right, such that their sum equals k, right, which is 9. Okay. So by by looking at it, right, we see that 5 and 4, right, there's a, a match, right, and then this could also been a match, 3 and 6, which gives you a sum of 9 as well, right? So we just need to return true, right? So that means we only need to find one of them, that one solution that fits the constraint, right? And then we're good. That's all that we need to do, right? Okay, guys, so what we're gonna do, okay, let's look at the second example first before we start talking about solutions, right? So this is the BST and this is the K value. There are no pairs, right? That equals 28, right? Yeah, because there's not even close to the number that's in the 20s, right? So yeah, so therefore we return false because there are no solutions for that particular input, right? Because all the values are pretty small and they want a huge sum, which is 28, right? So it's pretty obvious in this one, right? So how can we go about solving this problem, guys? What kind of logic do we need to solve this, right? We could start with brute force, guys. By the brute force solution is for I don't know, how do we generate every pair of numbers, right? And see which one can lead to can yield the sum that they're asking for, right? We could try all the 5, 3, 5, 2, 5, 4, 5, 6, right? You could do it like that. Is that how? But it's not gonna be optimal, I bet, because you need to check every single one, right? It doesn't make sense. We're doing kind of unnecessary work, guys, right? Just like the brute force solution that we did when we first started the two sum, right? So checking every possibility, right? So we could optimize a bit, right? Let's see by writing stuff here, guys, right? So we could see that what's it called? Uh we see that x plus y, guys, right? Say it's the two number, right? Two different nodes values, right? And the BST, right? Equals k, right? So that's a valid solution, right? Okay. Valid solution, right? So if we get those two numbers and their sum, right, of those two nodes values, right? Equals k, that's a valid solution, right? So what kind of server so how can we use this to our advantage, guys, right? So we need two numbers that equals k, okay? Two number that equals k. So as we're looping, so we know that we need to traverse the tree, guys, right? Traverse the tree, right? And check the nodes values, right? So we know that we have to do that to get traverse, right? So maybe as we're traversing, guys, right, we can, since we'll know at least one of those variables for sure, right? So let's say one of the nodes values that we're visiting right now, right, is x, right? But we don't know if there's exists a y in the rest of the binary search tree, right? That will help me to complete so that our sum together k equals k, right? So what we're gonna do at every node, guys, right? Since we already know that node's value, right? We're gonna check, right? We're just gonna apply simple algebra here, right? So we're gonna need to solve for y, right? So to solve for y, right, what we're gonna have to do is to check. So that means that we'll need to have some kind of a data structure, guys, right, to let us know if as you traverse, as you've been traversing the tree, right, if you have seen a y before, right? Have you seen a y, right? So if just like the same concept that we use up there, right? We check, have you seen this other number, right? This complement, right? Have you seen this other number that will help me those two numbers equals k, right? So the algebra thing that we're gonna do is since we know x, right? We're gonna say y. Let's go to k minus x, right? So by doing that, guys, we're gonna check every time in some kind of data structure, which is called a. We're gonna use a map or a set, right? Will suffice because we don't need to know any extra information. We just need to know if we have seen that number before, right? So as we're traversing, guys, right? We're gonna know x. We're gonna know before you get to me, right? Have you seen a y before, right? If you've seen a y, then I can say cool. Then I am good. We have found a perfect match. We have found a match, and we return true, right, for that particular match, right? So this is how it's gonna work, guys, right? So the map we traverse, so they go through an example. We put so in for 5, right? We check has is have you seen a 9 minus 5, right? Before have you seen a 4 before? No, because we're starting at the roots, right? So it's not gonna be there. So we go there at 3, we check 3. Uh 3 is gonna do this exact same thing, guys, right? It's gonna do 9 minus 3. Have you seen a 6? No, you have not seen a 6 yet because we have not visited this part yet, right? So that's why we're doing that. And we go to 2, and then 2 is gonna check. Have you seen a 9 minus 2, a 7, right? No, we have not seen that, right? So and then we go to 4, and then 4 is gonna do 9 minus 4, right? Which is its value, guys. Remember, I explained it, right? So we do. Have you seen a 5? Actually, yes, I've seen a 5 because as we're traversing, guys, right, we're also adding every node's value to the set, right? So that we can account for them, right? Okay. So when I'm going and when I'm saying it, let's go to the left, right. We're also as we're visiting nodes, we add it to the data structure, the set, right? So that once a node, right, uh, so that every node can check, right? Does is there a y, right? Is there a complement that exists in the set, right? That would make the another number that would make it a perfect match, which means that their sum, right, would equal k, guys, right? So very, very similar concept. So let's quickly go ahead with the implementation. Hopefully you guys were able to understand the thought process, right? So I'm pretty sure the code is going to make a lot more sense to you guys, right? So what we're going to do, guys, or we're going to create a helper function, right, which will return on the true or not, right? So we're going to pass in the root, that's important. We're going to pass in k, okay, which is important as well, right? And we could set true, right? Reset, and then you show new asset, okay? And then we're going to pass in the set right there, right? So now we're going to have our private function, okay? So we're just going to copy some of the signature from above. And then we'd also need to pass in the set, right? Because the set is going to help us in referring to previous numbers that we've seen, right? So we're going to have a simple check, guys, right? If the root equals null, return false, right? Okay. Else, right? So what we're gonna do, we're gonna do a couple of checks here, right? So this is where our logic is gonna make sense, right? So hopefully you guys will understand that, right? So what we're gonna do here, um, we're going to see, guys, right? If set contains, right? We turn that off. So if the set contains uh k, remember I was telling you guys k minus, right? The root or the node value, right? So if the node that we're on, right? if it contains k minus that, right, which is the other number y, that will help me make this complete so that those two sums, right, equals k, right? So make sure you guys understand that, okay? Since we know that one of them we could just do k minus root that value, right? So if that's true, guys, right? If we find that match that we're looking for, we're simply gonna return true, okay? Otherwise, if there's not exist that number yet, right, we're just simply going to add that current node's value to the hash set, guys, right? And after that, guy, we visit our left and our right, right? So we need both answers from the left and the right subtrees, right? So that's exactly what we're going to do. We're going to visit those as well. So root that left, pass in k as well, and pass in the set, right? We care about either one, right? So pass in the right as well, okay? Pass in k, and we pass in the set. Looks good to me. We have our data structure that's going to help us and refer to previous numbers that we've seen before, different previous nodes, right? And we loop through the entire thing, right? Looking for that perfect match. So as soon as we find that perfect match, we are in good shape, right? And we return true. Okay. So let's press run code, see if we pass the small test case. If we pass the small test case, press submit. Awesome, guys. We passed all the test cases, guys. So if you guys found value, make sure go ahead and give me a like, guys. If you guys are new here, make sure to subscribe because I'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.